So you just saw a very simple example of creating a simple WCF service and then calling it from a WPF application. Let's explore some more advanced scenarios. So we're going to see a demo where we bind to a list of customers. And what we're going to do is display customers in a list box, and then we're going to see the details for each selected customer in text boxes in a grid, which is similar to what we saw in the previous demo, but there is a difference. So we're going to call the WCF service to retrieve customers, and then we're going to set the item source property of the list box to results of the service call. That's the same, but what's going to be different is when we select a customer in the list box, we're then going to call the service to retrieve information for the selected customer. So in the demo we just saw, we brought down all of the information at once. In the next demo, we're going to see the flip side of that, which is only bringing down the information the users look at, which is the customer names, and then of course we need the customer ID. And then when you select a customer, going back and calling the service to retrieve information for that particular customer. Then we're going to set the data context of the grid to the customer object. And then we're also going to call the service because we want to know how many orders were placed by the customer, and then we're going to show that in a text block. What if you just want to bind to one customer? I mean, clearly if you call your credit card company, they don't pull up a list box with every single one of their customers and then scroll down to find you. No, they ask for a unique identifier, like your credit card number or something like that. So we'll see an example of that. The window is going to pop up empty, then you enter a customer ID and click the Find button, then the code is going to call the WCF service to retrieve the information on that customer and display it in a grid. What about related data, customers and orders, categories and products, etc.? Well, we're going to see an example where we display categories in one list box and the products in that category in another list box, and then below the products list box, detailed information on each product. So we're going to call the WCF service to bring back information on the categories and the products. And in our example, we're going to bring down all of the information at once. We'll talk about that a little bit more in depth when we get there. We're going to create a products property to the category class that contains the products in that category. Then we'll set the item source property of the first list box to the list of category objects, the item source property of the second list box to the products in that category, and then set the data context of the grid to the individual product that has been selected. And of course, users typically want to be able to modify the data. So we're going to call methods of the WCF service to add, edit, and delete data. Let's go see all of these in our next demo. I've got the WCF Services demo solution open, and I have two projects in here. WCF Services demo is my client application, and it has windows for each of the demos we want to show. And then also in here is the Northwind WCF Service project, which is a web host and WCF Service all-in-one project. And the service is called Northwind Service. And as the name suggests, it's going to be able to supply information on customers, categories, products, etc. So I'll run the demos first, we'll see what they do, and then we'll go and look at the code. So here's my sample application. First thing we want to look at is retrieving a list of customers. So when I click this, the window loads and displays customers in the list box, customer name, and then the city and the country. And as I select a customer, I can see additional information on that customer, including the number of orders they've placed, in text boxes in the grid below. Okay, so let's look at the code to do that. Our first example is retrieve customers. There's the code, there's the XAML. There's nothing WCF service specific in this XAML. I'm handling the selection changed event of the list box. I've got a data template that tells the list box to show company name and then in parentheses the city and the country. So that is that. And then when I select a customer, I'm going to set the data context of this grid to that selected customer, and then the text boxes are bound to properties of the customers. So there's nothing really new there. Let's look at the code. When the window loads, I create a new instance of the proxy class, Northwind Service Client. So when I added a service reference to this, when I added a service reference to the Northwind WCF service, Visual Studio created this proxy class, and then call getCustomers and bind that to the list box. This method, of course, is defined in the service. Let's go look at the services interface. The getCustomers method returns a list of customer summary classes. Because I'm being a little bit more clever here, I'm not going to bring down all of the information on every single customer all at once. In the previous demo, we did a select star from customers, essentially. This time, I don't want to do that. I just want to bring down the information that appears in the list box. So I have a class called Customer Summary, which brings down customer ID, company name, city, and country. Company name, city, and country are displayed in the list box. And then, of course, I need the customer ID to be able to go back and get additional information on the customer. Then in my customer class, this contains all of the customer information. So when I call getCustomers, I only bring back certain information. And that's what I'm doing when the window loads. Now when I select a customer, I get the selected item, which is an object, cast it to an instance of Customer Summary so that I can read the customer ID, and then I call the getCustomer method of the service, and I pass the customer ID. The getCustomer method sends back a customer. It sends back a single customer object. And the actual code behind the scenes is just simple ADO.NET. Nothing terribly complicated in here. So when I call customers, I just get customer ID, company name, city, country from the customers table ordered by customer ID, create a collection of customer summaries and send that back. And when I get customer, select star from customers where customer ID is equal to the ID of the customer we selected. Build a new instance of the customer class, checking to see if there's nulls. If you're using a data set, then that handles nulls pretty well, but if you're sending data over the wire, WCF Services and the data serializer don't particularly like nulls. So I'm checking to see if anything is null, because if it is, I'm setting it to empty string. So I check everything, and then I send back an instance of the customer class. So getCustomer returns a customer, and then I bind the grid to that customer, and therefore I see the information on that customer. Now I want to know how many orders this customer has placed. So I then call the orders count method of the service. The orders count method takes a customer ID and returns a number, because all it's going to do is, where's that code? Here it is. Because of course all it's going to do is select count from orders where customer ID is customer ID, send this back as an integer. So I make this call, I get back the number of orders, and I display it in the orders count text block, which is right here. So this is pretty efficient. I just get the information that the user is going to see when I open the window, and then I only retrieve the additional information when the user wants it. So I'm making more calls across the wire, but I'm only bringing down the information that I'm actually going to use at any point in time. So that's our first example. In our second example, this is more equivalent to what happens when you call the phone company or the credit card company and they ask for a unique identifier. I'm not going to bring down all of the customers. Even though in Northwind we only have 91 customers, are you really going to scroll up and down a list and look at all 91 customers? Maybe, maybe not. But in this case, when I enter a customer ID, I click Find, and then I bring down the information for that customer. I want to look at a different customer. I enter that customer ID and click Find. And that is in the Retrieve Customer example. So here's our window, and in the XAML, I just have a find text box, and then I handle the find button click event, and then the grid's going to be bound to that customer, and the text boxes work the same way. So what happens when we do this? Again, we create a new instance of the proxy class. And then when the user clicks the Find button, we call getCustomer, passing the ID. And then we bind the grid to whatever comes back. So this is actually pretty similar to the code we saw before in the selection changed. We called getCustomer and passed a customer ID, which is a string. In the previous example, we grabbed it as a property of the customer object in the list box. Here, we just take whatever the user entered. And then again, we call the orders count method and pass what the user entered. So looking at the interface, both getCustomer and orders count take a customer ID, and then presumably, I was checking to see if this code converted to uppercase or not. I guess it doesn't matter. I enter the customer ID in either uppercase or lowercase, and the service doesn't care. So I enter Alf key in uppercase, it comes back. I enter Anton in lowercase, it comes back. Doesn't matter. If it mattered, then I could either handle it on the client or more likely handle it at the service. I'd probably be more likely, where's the service code? I keep clicking on the wrong thing. I'd be more likely to handle it in the service and convert it to uppercase here. That way, I don't need the client developer to have to worry about it. But in this case, it doesn't matter at all. Okay, so that's retrieving one customer at a time, retrieving multiple customers at a time. Let's look at retrieving related data. So when the window appears, I'm showing the categories, and I'm showing the description in parentheses. And when I select a category, I see all of the product information. I see all of the products in that category, showing the name of the product and the supplier. And then when I select a product, then I display additional information in the text boxes in the grid below this second list box. Select another category, I show all of the products in that. So that is the related data example. Here's the code, here's the XAML. I have two list boxes, one called categories list box, one called products list box, and then a product grid. And each of the list boxes uses a data template because the categories show the description, products show the supplier. So here's the description and here's the supplier. And then the text boxes in the grid show one product at a time. And so I'll set the data context of that grid, and then the text boxes are bound to properties of the product object. So, what's the code look like? Window loads. I create a new instance of the proxy class, And then I call the get categories and products method and bind the categories list box to that. So get categories and products returns a collection of categories. There's also a get products method in here which takes a category ID and returns a list of products. But we called the get categories and products, so we're sending back a list of categories. And if we look in the category class, we see that categories have a property called products, and that is a collection of products. So the category object has the category ID, the name of the category, the description, and then a property that contains all of the products for that category. And so what I'm doing in this example, when I call get categories and products, is I'm actually sending back everything. So in my code, I create a new data set, I bring down categories, put that in the categories table, then I bring down all of the products, put that in the products table, then create a relationship between them, and then fill out the list of categories, and then fill out the products for each category. And so at the end of this categories contains all 8 categories and all, how many products are there in Northwind? It's less than 100. So absolutely everything's in here. And I send that back to the client. And then I bind that to the categories list box. So now, this list box contains instances of each category. When I select a category, then I'm going to get the products in that category. This is a list. It's an observable collection of products, and I bind the products list box to that. So I don't have to go back to the service to get the products because they're already contained in the category objects. And then when I select an individual product, I bind the data context of this product grid to that product to show the details. Now the benefits to this is that I make one call to the service and bring down everything. Is that a good idea? Maybe, maybe not. If it's a small amount of information, you can certainly get away with it. We have 8 categories and, I don't know, 70-something products. It's not that big a deal. Obviously, if we had 100 categories that each had 100 products, we wouldn't do this. We would, each time we selected a category, we would call the get products method and bring back the products for that category. But with smaller amounts of information, we can actually get away with what we're doing here. And it wouldn't be that hard at all to modify this code to go that other route. We could call get categories instead of get categories and products. And then in the selection change, we could call get products, passing the category ID, and then the code to bind the grid to the selected product would be the same. So not very hard at all to change this if we wanted to make multiple shorter calls instead of the one big fat call. All right, in our final example, we want to look at data entry. So here's a typical data entry window. I enter a customer, retrieve the information. Then I want to be able to make changes and save those. I want to be able to add a new customer. Corp, contact name Robert, contact title President, Redmond, can't type today, Washington. I want to be able to save that customer. And then if I go to ALF-key and then if I type TBD, I retrieve that customer, then I want to be able to delete it. There we go. So data entry. Let's see how we do that. This is going to be fairly straightforward. So when the window loads, we create a new instance of the proxy class. And then the find button code is the same as we used before. Call the get customer method, which brings back a customer. Set the data context of the grid. Let's bring this back up. Set the data context of this grid to that customer. And therefore, all the text boxes are bound to properties of the customer. We see the customer information, and we record that we're in edit mode. And the reason we need to know if we're in edit mode is because when we save information, we need to know whether to call the update customer method of the service or the add customer method of the service. So if we're in edit mode, we're going to call update customer. Update customer takes all of the customer information and returns a Boolean, true if it worked, false if it didn't. Add customer does as well. Looking at this, I'm not 100% sure why I didn't just pass the customer class instead of each of the individual pieces of information. That might be a nice enhancement. It'd be a little less code to write. And I honestly don't know why I didn't do that. Oh well. So I call the update customer method, passing the information to update the customer. And if it worked, the customer information was saved. If it doesn't work, the customer information was not saved. And in the actual service, update customer takes this information and calls an update method, adding as a parameter each of the pieces of information, and we return whether or not the number of rows changed was not 0. If the number of rows changed should be 1, then we return true. If we're adding a new customer, then we call the add customer method. If that returns a true, report that. Otherwise, report that it wasn't added and go back into edit mode. And then the add customer first checks to see if we sent any nulls. If they are, let's make them string empty. Then we just call an insert. And again, report back if the number of rows changed, which should be 1. If it's not equal to 0, then we return true back into the client. So to save customers, we make a call to the service, either update customer or add customer. And so we'll make a call, click save. The customer information was saved. Now if I start making changes, Brown in Munich, change the postal code, and then I decide I want to undo this. Do I want to undo all my changes? I say yes. Now I had two choices here. When I wrote this, I was thinking, what do I want to do if the user undoes? I didn't necessarily want to save all of the information that they had entered and then set it all back. So what I just decided to do on the undo is clear out the grid. So that's the very simplest thing. Everything gets tossed, nothing gets saved, and you haven't talked to the service. I suppose I could have redid the find. That would display the current information. So if the user brought down customer information, sat and looked at this, and then decided to do an undo, and I went back and retrieved information, then it's possible that, let's say in the meantime, somebody had changed this to 8 or 9, then when I click undo, data has changed. So I decided not to do that. I just decided to empty out the grid. But of course you could call whatever code you wanted in this case. And then if I click delete, I prompt, do you want to delete this customer? Which customer? Well, it is the customer that's in the grid, so I get the data context of the grid, which I know is an instance of the customer class, but it's an object in code. Cast it to customer so that I can read the ID, and then I send that to the delete customer method. Returns true if it worked. Then I display that and empty out the grid. Otherwise, I'd display the customer information was not deleted. So there's a fairly simple data entry form, finding, adding, deleting, saving, all by calling methods of the service. When you bind to a collection, WPF creates a collection view. And that view manages currency, which is the position of the current item. And you can also use views to navigate, sort, filter, and group. So if you want to do these things in code, then you need to be able to get a reference to the view. And to do that, you can use an instance of the iCollectionView interface. And to get an iCollectionView object, you can use the view property of the CollectionView source, which is the XAML representation of the view. So let's look at CollectionView source in a little more detail. This is the XAML representation of the view. Now you can define your views in XAML, and you can define them in code. Why would you do them in XAML? There's a couple benefits. First of all, if you use drag and drop data binding, then Visual Studio creates your CollectionView sources for you automatically in XAML, so it's less code that you have to write. And Visual Studio sets up the CollectionView sources to automatically handle one-to-many relationships. So here's an example of a CollectionView source in XAML. This CollectionView source is called Products View Source, and it's based on products, which could be a list in and of itself. It could be a property of the collection. It could be the products property of the categories class. And we'll look at these a little bit more when we get to the demo. Now, once you have a reference to the view, then you can do things like navigate. You can call methods like move current to first, move current to previous, move current to next, move current to last. And you can also use properties like current item or current position. So the navigation methods obviously give you the ability to put on a window first, previous, next, and last buttons and let the user scroll through a collection. You want to know which item you're on? That's current item. You want to know the position of the item you're on? That's the current position property. If you have a view, you can also sort in code. Now, of course, you can sort in your query. So if I want to sort by customer, I can put an order by on my original query. But when the data comes back, I don't want to have to go back to the service and say, oh, I really wanted to see these by city. So make another call to the service and have the service tell the database server, bring me down customer, sort it by city, and then the service converts that to XML and passes it to the client. That seems a pretty inefficient way of just looking at a list in a different sort order. So I'll use a view for that. And the sort descriptions property of the view contains a collection of sort description structures. And the sort description specifies the column that I want to sort on and the order. So to add a sorting order, you add a sort description to the collection of sort descriptions in the view, and then to clear the sorting, you say clear. And at that point, the view goes back to the original order. You can also filter if you have a view. You set the filter property of the view to a callback method, and this callback method will be code, could be simple code, could be very complex code, doesn't matter. But that code's going to determine whether or not each item in the collection should be included in the view. So the callback method returns a true or a false. It could be simple, country equals USA. If that's true, then that customer is included in the view, which means it will show up in the list box or the grid or whatever you're using. If false, then the customer doesn't show up. It's still in the underlying data source locally, but it's just not in the view. And then to clear the filter, you set the filter to null or nothing depending on whether you're using C# or VB. And at that point, every item in the view would appear in the user interface. So let's go see how we can use views to enable navigating as well as sorting and filtering in an application. I have the WCF Services demo application up and running. Let's take a look at the last demo in it. And here we're going to use a collection view source. So when I open this window, the application calls the WCF service and brings back a list of categories, and those get displayed in the list box. And then when I select a category, I want to look at the products. Now in the previous demo, let's just go back and look at that. When I clicked a category, I displayed the products in a list box, and then I could see additional information in these text boxes. But in this example, I want to do it a little differently. I still have the categories and the products, but when I select a category, I want to be able to view all of the products, but I want to see them one at a time. And then I want to be able to navigate through all of the products, going forwards and backwards. So I have a next button, a previous button, last, first, and then I also want to be able to sort products by name, and then sort products by supplier, and within each supplier, sort by name. And then I want to be able to see products that are low in stock, where in stock is less than 10, and then I want to be able to clear that filter and see them all. And then if I select a new category, I want to be able to do the same thing for the products in that category. So when the window loads, I'm going to create a new instance of my proxy class, Northwind Service Client, and I'm going to call the Get Categories and Products method of that service. This is the same code from the previous demo, and we bring back instances of the category class, and the category class has the category information as well as the products property, which contains all of the products. And now, when I select a category, first thing I want is a reference to the products. So this products field is a list of instances of the products class, and it's defined up here in the declarations as list of product. So then I get the products property of the selected category and convert it to a list of product and put that into products. Now why am I doing this? I'm doing this because I want to populate this collection view source. What's a collection view source? That is defined in the XAML, and the collection view source is the XAML representation of a view. So here I have this collection view source here called products view source, and the source is going to be products. And the nice thing about collection view sources is they handle one-to-many relationships if necessary. They also provide me with the ability to get the view, and the view gives me the ability to navigate as well as sort and filter. And Visual Studio will create collection view sources for you if you drag and drop out of the data sources window. So if you drag a table onto a window, create a data grid or a list view, then you get a collection view source. Or you can type them in XAML, which I've done here. So anyway, I have this collection view source, and then I need to be able to work with it in code. So my code says go get this products view source from the resources, cast it to collection view, and then populate it. So set the source property of this view source to the list of products belonging to this current category. Then I can get the view, which is an instance of my collection view, so that I can move current to first. So basically what I'm doing here is I'm getting a reference to the underlying view so that I can navigate, sort, and filter. And then when I click Next, I call the Move Current to Next as long as I'm not on the last item. If I click Previous, I move current to Previous as long as I'm not on the first item. If I click the first button, I move current to first, and if I click the last button, I move current to last. So because I have the view, I can loop through the view of products in the selected category. I select a different category, my view now contains different products, and I can loop through those. I can also sort by ID or by name or by supplier. If I sort by ID, which is the default sorting order, that's the way these items come out of the service, then all I need to do is clear the collection of sort descriptions that belong to that view and move to the first item. Now if I sort by name, I'm going to first clear the sort descriptions, and then I'm going to add a new sort description specifying that I want to sort on product name in ascending order. So I pass the property to sort on and the order, and then I move current to first. If I want to sort by supplier, I clear out the sort descriptions and add a new sort first on supplier and then on product name. So if I'm sorting by name, these products are sorted just by name. If I sort by supplier, they're sorted by supplier, and then within each supplier, there's a good example, they're sorted by product. And then if I want to go back to the original order, which was product ID, I just clear the sort descriptions. Now the other thing I can do if I click low stock, I want to filter. And when I click this low stock button, I'm going to set the filter property of the view. I can make this a little shorter. There we go. Now we can see the code. So I'm going to set the filter property of the products view. And the filter property is a predicate. So I set it to a new delegate, and I'm going to pass in each product one at a time, which is an object. I'll cast that to product, and then I'll read the units in stock property. If that's less than 10, then this delegate returns true. So basically what happens is, for the filter property, you create a method, an anonymous method. And you pass in each product in the view. And then this code runs for every one of the products, and if it returns true, the product is included in the view, otherwise it's excluded. Of course, all the products are still local. I haven't thrown out any data. It's just a question of whether or not they're in the view, and if they're in the view, they'll be displayed in the window. So after I click low stock, I'm only going to see the products where in stock is less than 10. And then if I want to clear the filter, I just set the filter property to null. And now I'm going to see all of the products in here. So we need to understand a little bit about this filter property because we need to be clever. This code is going to run for every single item in the view. Now if I have 12 products in here and I'm just reading the units in stock property, that's going to be very fast because it's all in memory. The collection of products is in memory, and then I just read a property of that. This will happen very fast. Even if I had hundreds of products in the view, how long can it take to read property, to loop through them all and read a property? That's very fast. But let's think of a different scenario. Let's say we were looking at customers, and we wanted to filter on premier customers. What's a premier customer? Well, a premier customer is somebody who has placed at least 100 orders in the last year and has averaged at least 75 orders a year for the past 10 years, and last year their average order was $50,000 or more, and over the past 10 years they have paid at least 80% of their bills within 90 days. And we have 200 customers in the view currently. Well, now we're going to have to rethink this because in order to filter, we're going to have to run 4 calls to the WCF service, and then those are going to have to call a database, and we're going to have to do that 200 times. So that's 800 calls to the service to filter premier customers. We might need to rethink that. But in this example, we don't have anything to worry about. We're just reading properties of objects that are already in memory. This example shows that we can use the collection view source and get a view, and then once we have the view, we can do things like navigate, sort, and filter.